As the threat evolves, we're going to be able to evolve with not only the airplane itself, but the mission systems that go in it to provide us advanced capability, because we want to stay ahead of the threat, and that's the goal.
Back in the day, the U.S. Air Force quietly built an aircraft so powerful and terrifying that it seemed straight out of a sci-fi thriller. It was called X-44 Manta. Fast forward to today, and that very same tech is reappearing under the mysterious NGAD, Next Generation Air Dominance Program. But why was the Manta project shelved in the first place? Did the Air Force create a monster too powerful to control? The innovative design of the X-44. Lockheed Martin, you know the name, right? These are the people behind some of the most iconic aircraft in history. Just think about it. This is the same crew that brought us legends like the F-117 Nighthawk, the sleek subsonic attacker you've probably seen lighting up the skies in Call of Duty. But that's just the start. They also gave us the C-130 Hercules, the lightning-fast SR-71 Blackbird, the sky-surfing U-2 Dragon Lady, and of course, the F-35 Lightning II fighters. But here's the kicker. The X-44 Manta might hold secrets far more shocking than anything these legends have revealed. Curious? Just wait. This isn't the only revelation that's about to drop. With Lockheed's hand in nearly every major U.S. aerospace project over the last 5 decades, it's no surprise not all of them made it to the finish line. One such ambitious project is our star today, the X-44 multi-axis no-tail aircraft, a.k.a. the Manta. But why name it Manta? Here's the scoop. The X-44 belonged to the X-Plane series, a collection of experimental aircraft pushing the boundaries of flight and tech. So what was the Manta aiming for? It had 2 bold missions. First, it wanted to be the first tailless manned aircraft capable of steering by redirecting its engine thrust alone. Imagine the perks: faster speeds, lower fuel use, and some seriously impressive aerial moves. Secondly, the Manta hoped to prove that aircraft could be cheaper and simpler while keeping their lethal edge. Even NASA was intrigued, eyeing some of the Manta's tech for other U.S. warbirds, like the F-22 Raptor and F-15 Eagle. The X-44 didn't just copy-paste the design of Lockheed's F-22, it pushed every boundary to reimagine what a combat jet could be. Turns out, Lockheed didn't just tweak the original design of the X-44 Manta, they tore it apart and rebuilt it with a bold, tail-free look. Imagine a plane without the classic tail. Instead, the Manta resembles the legendary Northrop B-2 Spirit bomber. But this wasn't just a makeover, it was a masterstroke in stealth. Losing the tail was key to keeping the plane invisible on enemy radars while still letting it glide and twist through the skies with ease. How did they pull this off? The secret was in the engine nozzles, designed to tilt in multiple directions for top-notch steering. Now, here's where it gets interesting. Lockheed offered 6 different F-22 style designs to the U.S. Air Force, but none passed the test. So what caught NASA's eye? The rough blueprint of the Manta sparked their interest, and they saw potential in it. They revamped the engine, reshaped the body, slapped on some triangular wings, and ditched the tail entirely. The result? The X-44 was looking nothing like the F-22, and thanks to its redesigned wings, it could carry even more fuel than the Raptor, a huge bonus for long-range missions. So what was the Manta meant to carry? This was no ordinary fighter. It was designed to pack a serious punch while staying under the radar. The idea was to store a whole arsenal inside the plane, similar to the U.S. stealth bombers. Think Sidewinder missiles for up-close dogfights, AMRAAMs for long-distance strikes, hefty 1,000-pound bombs, and laser-guided mini-bombs. The plan was to keep 2 large fuel tanks under the wings and throw in a powerful cannon. And just how fast could this beast go? The Manta was built to reach a jaw-dropping 1,500 miles per hour with a range of nearly 2,000 miles and soar up to 49,000 feet. Fueling this powerhouse were 2 massive engines with a combined thrust of 70,000 pounds. Quiet, stealthy, packed with firepower, and agile, the Manta was supposed to bring it all without breaking the budget. So what went wrong? The funding was pulled in 2000. Why? Was the Manta too good to be true? The truth is, big aerospace projects often hit these crossroads. Companies have to prioritize, and sometimes that means shelving promising projects in favor of others, like rolling out more F-22 Raptors or advancing the F-35 Lightning II. But let's be real, the Manta wasn't just a fantasy. It hinted at the future of aerial warfare. That's the reality of aerospace. Hard decisions and tighter budgets can mean the end of one dream to make way for another. And while the Manta didn't see the light of day, it left behind some tantalizing possibilities for what the future of stealth and air combat could be. For the Manta, the dream of soaring through the skies came to an abrupt end. Lockheed Martin's story with the X-44 Manta is a classic tale of aerospace ambitions running into hard reality. Creating cutting-edge designs and technologies that redefine aviation is no easy feat, and sometimes even the boldest projects don't make it past the blueprint phase. The Manta's journey is a prime example of the difficult calls engineers and investors face. But here's the bigger picture. Even when a project like the Manta doesn't reach the runway, it pushes the boundaries of what's possible and adds to our collective knowledge of flight. The Manta project, for instance, wasn't just scrapped. It's a milestone in a relentless quest for speed, stealth, and firepower. Did canceling the X-44 mean the end for these innovations? Not quite. The project was folded into an even grander vision for the U.S. Air Force's sixth-generation stealth fighter, the Next Generation Air Dominance (NGAD) program. While projects like the Manta may have been shelved, their legacy fuels the ambition behind the U.S. Air Force's groundbreaking NGAD program, especially in light of global advancements in fighter jet technology. What is NGAD, and why does it matter? You know, a nation's Air Force is only as powerful as its air strength, measured by the quality and quantity of aircraft it maintains. Other key factors include the skill of its personnel, logistics support, and readiness for rapid mission deployment. The United States Air Force proudly excels in each of these areas, giving it a significant edge over its closest competitors: China, Russia, South Korea, and India. What's even more impressive is the sheer scale of the USAF's dominance. It commands an air power greater than the next 5 air forces combined. With 1,324 aircraft, the USAF boasts 25% of the world's military aircraft. Equipped with cutting-edge jets like the F-22 Raptors and F-35 Lightnings, the Air Force is ready for air combat across all terrains. These fighter jets, known for their stealth and maneuverability, make them a formidable threat to any adversary. Yet, even with this unparalleled air supremacy, the United States is far from complacent. Continual investments in military technology and innovation ensure the gap between the USAF and its rivals only widens. Each new development adds to an already impressive arsenal, pushing the boundaries of what's possible in air warfare. In the past year, the Chinese and Russian air forces have made significant strides in advancing their fighter jet capabilities. What exactly are these advancements? Russia is working on a 6th-generation engine design for the Su-57, while China is focusing on enhancing its Chengdu J-20 Mighty Dragon fighter jet. These developments underline the growing importance of the U.S. Air Force's Next Generation Air Dominance (NGAD) program. The U.S. Air Force is pulling out all the stops to secure its air dominance well into the future. Once it completes its 6th-generation air initiative, dubbed NGAD, its rivals will face a whole new level of challenge. This ambitious program is designed to be the successor to the formidable F-22 Raptor, currently one of the most feared aircraft in the skies. The F-22 has been a force to be reckoned with, keeping potential threats at bay with its unmatched capabilities. Now, imagine an even more advanced jet taking its place. That's the NGAD program's goal, and the main attraction is its manned fighter, the Penetrating Counter-Air (PCA) aircraft. But the PCA won't be alone. It will fly alongside loyal wingman drones, known as Collaborative Combat Aircraft, CCA, creating an unprecedented manned-unmanned combat team. This collaboration represents a new era in air warfare, where manned and unmanned systems work in seamless coordination. Though most NGAD details are still tightly guarded, it's clear this program is a massive leap forward, promising capabilities that surpass any previous generation of aircraft. So yeah, the NGAD program aims to ensure that the U.S. retains its air superiority by developing a next-gen fighter to replace or update the aging F-22 Raptor fleet by 2030. Since 2015, the U.S. Congress has allocated over $4.2 billion to fund this initiative, according to the Congressional Research Service. However, details about the program remain tightly guarded, which raises the question, how much progress has been made and where does NGAD stand today? While we haven't seen many public updates, it's clear that NGAD's focus is not just on building one aircraft, but on creating an entire family of systems designed for air superiority. This includes unmanned drones, new sensor technology, and advanced weapon systems, all working together to maintain a tactical edge. Why is this so crucial? With countries like China and Russia enhancing their air force capabilities, the U.S. needs to stay ahead of the curve to secure dominance in future aerial combat. And what about the Navy? Interestingly, the Navy is pursuing its own version of NGAD called the F/AXX program, which aims to replace the F/A-18 Super Hornet. This means both branches are actively working on securing future air power dominance. The priority for the NGAD program is not just to build a replacement for the F-22 fighter jets, but to create a portfolio of technologies that will ensure U.S. air superiority for decades to come. What does this mean in practical terms? The Air Force isn't solely focused on developing one new fighter. They are also exploring various systems that could work together, from manned and unmanned aircraft to cyber and electronic warfare technologies. The Department of Defense defines it as the ability to operate freely in the air without prohibitive interference from air and missile threats. In other words, it's about having control over the skies so that the U.S. military can conduct its operations safely and effectively. The U.S. Air Force is actively developing 4 key technologies as part of this program, each critical to ensuring future air superiority. One of the primary areas of focus is propulsion. Through the Advanced Engine Technology program, the Air Force has been investing heavily in variable cycle engines, which are designed to significantly improve not only thrust, but also electrical power generation and cooling capabilities. Why is this so important? Enhanced power and cooling are essential for sustaining the high-performance demands of next-gen fighter jets, particularly when these aircraft are equipped with advanced weaponry and cutting-edge electronic systems. Another exciting development involves uncrewed systems. In 2022, Secretary of the Air Force Frank Kendall confirmed the active development of unmanned aircraft that will work alongside NGAD. While the Air Force has kept many of the specifics under wraps, analysts speculate these drones could take on a variety of roles, from intelligence gathering and electronic warfare to serving as additional carriers for munitions. The potential here is vast. Could these autonomous aircraft significantly reduce the risks for human pilots in future combat scenarios? It's a question that continues to fuel curiosity and debate in military circles. Material science is another key area of exploration within the NGAD program. The Air Force is experimenting with innovative composite materials and structures, as outlined in its FY 2023 budget. Specifically, there is a focus on developing low-cost design and manufacturing structural concepts for attributable vehicles, suggesting that these advanced materials may play a major role in creating uncrewed aircraft that are both affordable and efficient. Then, there's the matter of sensors. The NGAD program is pushing the boundaries of radar technology, infrared sensors, and electro-optical cameras. This new generation of sensors will likely provide unprecedented detection and tracking capabilities, ensuring NGAD aircraft maintain unmatched situational awareness in the sky. So you see, the NGAD's goal is a fleet of planes with no tails, and these aircraft aren't just going to fly solo. They'll work in tandem with drones known as Collaborative Combat Aircraft, CCA. Think of it as a team of stealthy, radar-evading allies in the sky, with the NGAD fighter at the center. The Manta's ideas were essential for this new project. While the X-44 was initially designed for a pilot, it was easily adaptable as a drone. Its tailless, radar-dodging design made it a prime candidate for autonomous flight. But if stealth technology keeps advancing, why aren't these planes completely invincible? Here's the twist. Even the best stealth planes have their own nemesis, something called infrared search and track (IRST) systems. These systems don't rely on radar. They use heat to detect and track aircraft, and that's making things tricky for America's stealth fighters. In recent years, other global powers have been pouring resources into these IRST systems, which can pick up on invisible planes and bypass traditional radar jamming tactics. With threats like these, it's clear why Lockheed Martin didn't fully abandon the Manta's advanced ideas. They're stepping stones for what's next in air dominance. The Manta might not have taken flight, but it laid the groundwork for a whole new level of aerial warfare. But what's really troubling for the US Air Force about these IRST systems? They're silent. A plane might not even realize it's been spotted until it's too late. But with Lockheed Martin's team on the case, it's safe to bet they saw this coming. Could they already have tricks up their sleeves to outsmart these thermal tracking systems? One possible solution: reducing the heat signature of the NGAD. Since IRST relies on detecting heat, a cooler plane would be almost invisible. And let's not forget that battlefields aren't always clear and sunny. In fog, rain, or that early morning haze, IRST struggles to track anything, giving the NGAD a window to slip in, complete its mission, and get back home unnoticed. Plus, the long-range capabilities originally planned for the Manta are being reconsidered for the NGAD, especially useful if this 6th-gen fighter is sent on lengthy missions in the Indo-Pacific region. Imagine two versions of this stealth fighter, one designed for quick trips in Europe and another fully loaded for those far-reaching heavy-duty missions in the Pacific. So here's a big question. Why didn't the Manta fly in the first place? Could it have been the limitations of its range, particularly in scenarios like a conflict in the Pacific? With technology advancing at breakneck speed, some of the Manta's challenges might have been that it was ahead of its time. Back then, combat lasers and AI-driven pilot helmets were still sci-fi concepts. However, the NGAD has no such limitations. The US Air Force now envisions the NGAD not as a single plane, but as a fully integrated system. Imagine the main fighter jet accompanied by a fleet of unmanned drones, known as Collaborative Combat Aircraft, CCA, or Loyal Wingmen. These aircraft would be linked through manned-unmanned teaming, MUM-T, allowing them to work together in sync. If such systems existed, why did they pull the plug on the Manta? It came down to practicality. At the time, other planes seemed more versatile, cheaper to produce in large quantities, and suited to multiple tasks. But the Manta's ideas weren't lost. Instead, they became the backbone of this larger, more advanced project, the NGAD, the next generation of air dominance. The NGAD program is more than just a high-tech fighter jet. It's a leap into the future of air combat, using cutting-edge strategies to ensure dominance in a world where staying undetected and nimble is everything. So how is the NGAD different from any other fighter program? It's not just one jet. It's an integrated system of manned and unmanned aircraft working in perfect harmony, designed to handle diverse missions, even when the skies get rough. This means that the NGAD could excel where traditional aircraft might struggle, keeping air dominance intact in any weather. In modern warfare, the ability to travel long distances without constant refueling is a game changer. It allows the U.S. to project its power far from home, especially in the vast Indo-Pacific region where quick response and extended reach are critical. The NGAD's promise of covering extensive areas without a pit stop could give the U.S. a crucial edge in conflicts where control of the skies determines victory. The NGAD project builds on groundbreaking ideas from earlier programs. Imagine stealth, advanced combat tech, and a seamless blend of manned and unmanned flight coming together. This isn't just a step forward, it's the foundation for the Air Force's strategy to maintain air superiority for decades. But what sparked this shift in focus? Air Force officials are moving away from the idea of one plane per mission and toward a flexible approach. And this isn't the first time they've surprised the world with innovative tactics. Remember the Rapid Dragon program, where they launch cruise missiles from a C-17? Or even back to WAU-2, when they dropped troops from a B-24's bomb bay. With this legacy of flexibility, Lockheed's ambitious ideas from the Manta are bound to find their way into NGAD's design. The Manta was a pioneer, the first tailless, manned aircraft using only thrust vectoring for steering, ditching traditional controls like rudders that can make a plane easier to detect. This meant the Manta was built for stealth, agility, and fuel efficiency. And here's the kicker: it wasn't just designed for piloted missions. This unique design hinted at a future where drones could play a big role. And now, NGAD is poised to bring that future to life. Imagine this: drones with the stealth and agility of the X-44 Manta, fearless in facing danger without risking a single pilot's life. Could they be the Air Force's secret weapon for daring deep strikes, or even decoys to draw enemy defenses out of hiding? With drones like this, dangerous missions wouldn't need to risk human lives. These aren't just cool tech ideas. They're real possibilities as we move into an era where manned and unmanned systems seamlessly join forces. So you see, the NGAD isn't just an advanced fighter jet, it's a new way of fighting. Imagine pilots and drones working together, with AI handling rapid in-battle decisions, freeing up human pilots to think about the bigger picture. What if one single NGAD fighter could handle missions that used to require entire fleets? That's the power of blending human and AI skills in the skies. So, even though the X-44 Manta's path ended, its groundbreaking ideas are very much alive in the NGAD. Could the tailless design and AI-driven control systems from the Manta make their way into the NGAD's DNA? The Pentagon might have shifted its focus to more traditional jets like the F-35 Lightning II for immediate needs, but the spirit of the X-44 hasn't faded. With the X-44's innovative thinking in mind, could we be looking at a future where drones take on even the most dangerous combat tasks, paving the way for pilots to handle more strategic roles? Time will tell, but Lockheed Martin's knack for breaking the boundaries of aviation is only growing stronger. As we step into a new era of air combat, don't be surprised if the spirit of the X-44 leads the way in reshaping the future of war in the skies. Then, there's the game-changing role of AI. Imagine it analyzing threats, making split-second decisions, and tackling immediate dangers, all at speeds no human could match. In the thick of combat, this could be a pilot's best wingman, letting them focus on the broader mission while AI manages the chaos. As the Air Force dives deeper into AI and unmanned tech, could the secrets of the Manta be the hidden key to the future of American air dominance? We'll have to wait and watch. Did the NGAD programs blow you away? Then brace yourself, because the U.S. Air Force's upcoming B-21 stealth raider bomber is set to take things to a whole new level. B-21 stealth raider bomber. So this cutting-edge aircraft is planned for a 2027 launch and is primed to replace the legendary B-1 and B-2 bombers. But what makes the B-21 so special? For starters, it's rocking the classic B-2 flying wing design, but with a sleeker, smaller frame. The payload? a hefty 30,000 pounds, half that of the B-2, but packing 2 generations worth of stealth tech upgrades. Imagine flying into enemy territory and slipping through radar like it's not even there. That's exactly what the B-21 promises. Undetected long-range strikes that'll make even the boldest adversaries think twice. Now, why does the USAF want this bomber in the big leagues? Simple. It's built for high-stakes missions, carrying nuclear and conventional weapons to support America's nuclear deterrent policy. Picture this. When conflict looms and the B-21 is in the skies, nations might just fall in line, reconsidering any notion of challenging the U.S. How's that for an aerial intimidation tactic? Northrop Grumman, the brains behind the B-21, is calling it the world's first 6th-generation aircraft. Yep, this isn't just any bomber. It's the most advanced in U.S. military history. We're talking digital engineering, agile software, and manufacturing techniques that minimize production risks, all ensuring that this bomber is as resilient as it is lethal. But just how many B-21s are in the works? Right now, 6 of these stealthy beasts are in various development stages, all being assembled and prepped for test flights at Northrop's Palmdale, California plant. This whole project kicked off in 2015 when the Air Force entrusted Northrop Grumman with the mission, leading the contractor to rally an 8,000-strong team of experts to make this dream machine a reality. So, the bottom line is that the B-21 Raider isn't just a bomber. It's a wake-up call for U.S. rivals like Russia and China. This isn't just a plane. It's the future of air dominance, stealth, and power that could redefine what aerial warfare even means. So you see, the B-21 program isn't just redefining air power, it's rewriting the entire rulebook. Thanks to its open architecture design, this bomber can be rapidly upgraded without the need for bulky block updates like its predecessors, the B-1 and B-2. So, what does that mean for the future? Think agile software upgrades and hardware flexibility that allow the B-21 to adapt to new threats as soon as they appear. If an enemy gets bold, the Raider will be ready, no questions asked. Here's where things get even cooler. The B-21 has both manned and unmanned capabilities, positioning it as the future backbone of U.S. air power. Integrating data, sensors, and weaponry, this bomber lets combat commanders pinpoint targets anywhere on the planet. It's got a mix of standoff and direct ammunition, giving it unmatched firepower. Maintenance? Tinker Air Force Base in Oklahoma has it covered, while Edwards Air Force Base in California handles testing and evaluation. This setup ensures the B-21 is always mission-ready. Could it get any more advanced? Possibly. There's talk of adding uncrewed long-distance wingman drones to assist the B-21. Imagine a fleet of drones coordinating with the Raider through ground stations and satellites. It's like something out of a sci-fi film, but real. The U.S. Air Force is eyeing at least 100 of these bombers by 2040, an investment worth billions. The exact cost is top secret, but we'll have a better idea once they're in action. But here's a piece of history that makes the Raider even more legendary. It's named in honor of the Doolittle raid from Wozwood, when Lieutenant Colonel James "Jimmy" Doolittle and his 80 airmen courageously flew B-25 bombers on a mission that changed the war's trajectory. This historic connection? It's a tribute to the legacy of air dominance the B-21 will continue. Now, is it even possible that the B-21 Raider will replace the iconic B-52 someday? Most likely. With the Next Generation Air Dominance (NGAD) and the B-21 program in full swing, the USAF is pushing the boundaries of what's possible in advanced aircraft design. And who knows? There may be even more futuristic military tech in the works that we don't yet know about. Like, one example is the drone, the loyal, Wingman. This isn't your typical drone. Nicknamed the Wingman Bomber, it's an AI-driven powerhouse that can team up with the best of the best, like the B-21 Raider and NGAD fighters. But what's the big deal? This isn't just any unmanned combat air vehicle, UCAV. It's cheaper, it lasts longer on the battlefield, and it packs a punch that rivals even manned aircraft. With its lower price tag and impressive capabilities, the Loyal Wingman is a major win for the USAF, giving them big results without the big spending. As part of the Air Force's Collaborative Combat Aircraft (CCA) program, the Loyal Wingman isn't here to play backup, it's here to lead. It's equipped with serious weapon-carrying power, rivaling human-piloted aircraft while ditching the heavy hardware needed for human life support. This UCAV is designed to follow a human-piloted aircraft, allowing the pilot to focus on big-picture command, while the Loyal Wingman handles the tactical action. So what exactly does the Wingman bring to the table? Imagine a machine that can scout as a sensor, fire like a shooter, and carry heavy weaponry, all while being virtually undetectable. Its advanced AI lets it fly independently, dodging threats and sticking it out in the heat of battle, all while acting as a force multiplier. It can cover a wider area than a single manned plane and even provides extra sensor coverage, giving the lead aircraft a chance to stay stealthy, cutting emissions and remaining hidden from the enemy. And it doesn't end there. With its autonomous brain power, the Loyal Wingman won't bog down the human pilot with micromanagement. Instead, it handles itself while adding firepower to any mission. Is this just an American idea? Not exactly. Countries like Australia, China, Russia, Japan, and the UK are also eyeing this tech. But given the US track record, don't be surprised if they're the first to make this game-changing concept a combat-ready reality, potentially building a wingman that outperforms the rest. In other words, this isn't just a sidekick. It's an autonomous combat partner. As sixth-generation fighters and bombers roll out, this AI-driven drone will be the ultimate backup, making the Loyal Wingman the star of the future skies. While the Loyal Wingman takes center stage, another USAF project shrouded in secrecy is bound to unleash its own brand of chaos in the skies. Project Mayhem. Frankly speaking, the US military has a reputation for keeping its biggest innovations classified, but the level of secrecy surrounding this hypersonic bomber is on another level. For months, the US Air Force has kept development under tight wraps, only recently letting a few details slip. And Mayhem isn't just a catchy name, it's a warning. This bomber promises chaos for anything in its path. Officially, it's called the Expendable Hypersonic Multi-Mission ISR and Strike Program. But what's the plan here? This stealthy hypersonic bomber is set to replace the iconic SR-71, and it's designed to take intelligence, surveillance, and reconnaissance, ISR, to a whole new level. With a recent $334 million contract awarded to top engineering firms, including Draper, the Air Force Research Laboratory has set the wheels in motion to bring Mayhem to life, pushing the limits of speed and technology. So what makes Project Mayhem so tricky to build? The challenge of building a hypersonic aircraft is that the intense heat generated at such speeds makes construction and testing nearly impossible. But where most would see barriers, these manufacturers see breakthroughs. Mayhem's planes are expected to reach speeds above Mach 10, making them faster than most missiles. And unlike missiles, this aircraft can be refueled and used again and again. And the tech under the hood? Pure genius. Project Mayhem's hypersonic aircraft will use a multi-cycle propulsion system, switching from a jet engine to hit Mach 3 to an air-breathing scramjet that kicks it into hypersonic overdrive. This dual-engine setup will let Mayhem cut through the skies like nothing we've ever seen. Once Project Mayhem is fully operational, the United States won't just be leading in hypersonic tech, it'll be leagues ahead of the game. With scramjet engines capable of reaching an astonishing Mach 15, this hypersonic bomber isn't just fast, it's practically untouchable. Unlike hypersonic missiles, which are one-hit wonders, this bomber is a reusable, cost-effective powerhouse. Its ability to outrun enemy missiles at over Mach 10 gives it free rein in the sky, making intercepting it a lost cause for any rival. But is this the end of the Air Force's super-secret projects? Not even close. The USAF is a master of classified programs, and what we know is just the tip of the iceberg. There are still mysteries lurking in hangars that haven't yet seen the light of day. Will the Air Force let us in on these hidden marvels soon? Only time will tell. But one thing's for sure, Project Mayhem is just the start of what's coming. Could the X-44 Manta be the U.S. military's most closely guarded secret, or just another tale shrouded in mystery? Let us know what you think in the comments, and remember to like and subscribe for more insights.